Probability and the addition rule. Probability of mutually exclusive events. From the name of mutually exclusive events, that two events cannot happen at the same time, so they are said to be mutually exclusive. Like in this experiment, when a die is rolled once, what is the probability of getting a 3 or a 4? Okay, from the Venn diagram, we have either a number 1 can occur, or 2, or 3, or 4, or 5, or 6. All of them they have no intersections between them, as you see in the Venn diagram. So when we ask what is the probability of getting a number 3 or a number 4, this means that it will be probability of getting a number 3 plus the probability of getting a number 4, because they are mutually exclusive, because they cannot happen together. Either you get 3 or you get number 4. So the probability of getting a number 3 or 4 will be 2 over 6, which is 1 over 6 plus 1 over 6. That is 2 over 6 or 1 over 3. So this takes us to the rule that says that for mutually exclusive events A and B, the probability of A or B happens is equal to probability of A plus probability of B when they do not have intersections between them. Let's take an example here to show what is the difference between mutually exclusive events and not mutually exclusive events. A card is drawn from a deck of cards, 52 cards. Determine whether the events are mutually exclusive or not mutually exclusive and explain your reasoning. The first one is drawing a 3 or a 2. Of course, we have either a card with 3 or a card with 2. So they cannot happen at the same time. So, of course, they are mutually exclusive. So this will be mutually exclusive. Number B, drawing a 7 or a red card. Of course, we know that there are 2 cards of 7 that are red and 2 cards of 7 that are black. So these are red and these are black in the deck of cards. So this means that drawing a 7 or a red card can happen together. And it can happen together, so they are not mutually exclusive in this case, and it will have another rule. We will talk about this later in this video. So it's not mutually exclusive. Part C is drawing a queen or a spade. We know that a queen can be a spade. So we have a queen that is black and another queen that is black, and 2 queens that are red. Okay, one of the black ones is spade. So this means that a queen can happen together with a spade. So this means that they are not mutually exclusive. Let's take an example here and look if it is mutually exclusive or not. Daniel organizes all of his social media contacts into 3 groups: close friends, acquaintances, and restricted. If the program sends Daniel an update from a randomly chosen contact, what is the probability that the contact is either a close friend or acquaintances? First of all, you have to determine if close friends and acquaintances, if these 2 events are mutually exclusive or not mutually exclusive. Of course, they are mutually exclusive because they cannot happen together. The friend can either be a close friend or acquaintance. So the first thing to do here is to find the total number of friends of Daniel. Total number, because this is the denominator of our probability. So the total here will be 68 plus 24 plus 10. And the answer is 102. So the total number of friends is 102. After that, you're going to find the probability of the friend to be a close friend or an acquaintance. So this means by our rule that because they are mutually exclusive, this is equal to the probability of a friend plus the probability of an acquaintance. So the word or means we add the probabilities. Okay, so the probability of a friend is 68 over 102. Plus the probability of an acquaintance is 24 over 102 as well. So the answer will be 92 over 102, and when we simplify, it will be 46 over 51. Okay, so the probability can be written as a fraction. It can also be written as a percentage or a decimal. So if we make it as a percentage, it will be 90%. The other part of probabilities, or the other type of probabilities of events, that if they are not mutually exclusive. So if two events can happen at the same time, they are not mutually exclusive, as we said before in the examples of the cards of the spade and queen and the 7 and red. When a die is rolled once, what is the probability of getting a number greater than 2 or a number that is even? So we have here numbers of even numbers. This is the probability of even numbers. We can write them, which is 2, 4, and 6. And the probability of, or the event of having a number greater than 2, that is 3, 4, 5, and 6. So these are the two events, greater than 2 and even numbers. Of course, they have intersection between them, because 4 and 6 is an even number and they are greater than 2 at the same time. So in this case, these two events are not mutually exclusive because they have intersection between them. In this case, what will be the probability of having a number that is greater than 2 and even, or because we're talking about or even at the same time. So if we add here, if we use the first rule, which is probability of the first event greater than 2 plus probability of even numbers, let's see what will be the answer here. Probability of numbers greater than 2, that is 1, 2, 3, 4, which is 4 over 6, plus probability of even numbers that are 1, 2, 3, that is 3 over 6, and when you add, you will get 7 over 6, and that is greater than 1. And of course, probabilities must always remember that probability of any event should always be greater than or equal to 0, less than or equal to 1. So there is something wrong here. So this means that there is something wrong in this rule. So we cannot use this rule as it is in the mutually exclusive events. Okay, so if we have here the probability of a number greater than 2 or even number at the same time. Okay, so we have even numbers here, 1, 2, 3, and numbers greater than 2 is 1, 2, 3, 4. But we have 4 and 6 are common in between both, so we cannot count them 2 times. So we're going to count 1, 2, 3, 4, 5. So the probability must be equal to 5 over 6. This is the correct probability. Okay, how can I find 5 over 6 from the probabilities of even and probability of a number greater than 2? We are going to do this by having probability of the greater than 2 plus the probability of even number, and that we found it was 7 over 6. But we're going to subtract from it here the probability of the intersection between the first event and the second one. The probability of the intersection between them. So let's find here if it is correct or not. So probability of number greater than 2 is 4 over 6 plus probability of even number that are 3 over 6, and subtract the probability of the intersection between them, that is 2 over 6. So if you do this, 4 plus 3 minus 2 will be 5 over 6. This is what we have got here. So this takes us to the rule of the probability of events that are mutually exclusive, which is probability of A or B. If they are mutually exclusive, is probability of A plus probability of B minus probability of A and B together. And the word "and" here replaces intersection. So probability of A intersect B. Let's have the last example here. A game piece is selected at random from the plate at the right. What is the probability that the game piece is round or orange? So here we have orange colors, we have blue colors, we have green colors. We also have 3 shapes or 4 shapes. We have a square, we have a pentagon, and we have a circle. So also we have the probability of round or orange. We look here, we can find that there are round pieces that are orange at the same time. So they are not mutually exclusive. So we're going to use the second rule, which is probability of round plus probability of orange minus probability of round and orange at the same time. So probability of round, we're going to count how many rounds there are orange pieces, minus the probability of round and orange at the same time, which is only 2. So the answer would be 7/10, that is 70%.